Hi, everybody. It's Professor Mitchell, and we're continuing with Chapter 7. Today, we're talking about Section 7.2, which is multiplying and dividing rational expressions. In this section, we will multiply rational expressions, divide rational expressions, multiply or divide rational expressions, and then finally, we'll end with talking about converting between units of measure. Which will be especially useful to those of you who are nursing majors. And this is the same SLO that we talked about in the last section. So let's get to it. So as I mentioned in the last section, rational expressions are kind of the algebra version of fractions. So often I like to relate what we're going to be talking about in the new section with something that you already know how to do with fractions. So in this case, we're talking about problems like this. So I know you already know how to do this. Let's just go over it really quickly. If I can get to the right screen here. Okay, so when you're multiplying fractions like, there we go, 2/3 times 5/11ths. That's just about the easiest thing in the world. There are no common factors between any of the numerators or denominators. So you just multiply going straight across, and the answer is 10/33. All right, what could be simpler? But if you're doing something like 3/8 times 14/15ths, what you do, and when I teach pre-algebra, I kind of insist that students show me all these steps because it is possible to mess yourself up if you do a shortcut. You have to find the common factors between the numerator and the denominator. So what I'm going to do in this case is write the 14 as 2 times 7. And then I'm going to write the 8 as 2 times 4, and I'm going to write the 15 as 3 times 5. And then I can get rid of those 3's on the top and the bottom. I can get rid of the 2 on the top and the bottom. And the answer in simplest form is 7/20. And I also want to point out that it's easier to do it that way than it is to multiply straight across first and get 42/120 and then sit there and try to figure out how to simplify 42/120. I think it's easier to simplify as you go along. All right, so what does this have to do with what we're going to be doing? Well, it works exactly the same way. So if I hand you two rational expressions and I ask you to multiply them, you multiply straight across, but take out common factors as you go. All right, so the answer always has to be given in simplest form. All right, and remember what we talked about in the last section. You can't simplify anything except common factors, okay? So here are the examples that we're going to be going over next. So I will switch back to the tablet and we'll take a look at those. All right, so the first one is pretty simple. I think this really is what I call a Math 81 problem. We don't have Math 81 anymore, beginning algebra, but I think we used to do this kind of problem in Math 81. You might have even had one in your review quiz. So there is no factoring to do here. Everything is already multiplication inside the fraction. So one suggestion I'll make is that you put a 1 underneath this y to the third, and then just start looking for common factors. So for example, 9 and 18 have a common factor 9. If you divide each of those by 9, that becomes a 1, this becomes a 2, okay? Now I'm gonna look at the x's, all right? So this is where we're gonna use our exponent rules. These did come up in the review quiz. X to the third divided by x is x squared. Remember, you subtract the exponents. All right, and when everything that's left is on top, what that technically means is that there's a 1 on the bottom. Of course, times 1 doesn't change anything, so we will leave that 1 out of the answer. Now, as far as the y's go, there are a couple different ways you could handle this. One way would be 5 minus 2 is 3, and because that exponent 5 is on the bottom, that's where the y to the third is going to go. All right, and again, a 1 up here. But then I have another y to the third on top, so now you can actually take the y to the third on the bottom and the y to the third on top, and those just cancel each other out. And again, they leave 1s. I'm not going to keep on writing those 1s. So now you just kind of pick through what's left. Notice that negative sign that was sitting outside. That we're not going to do anything with that. That's just going to get carried along. So then what we're left with upstairs is just x squared, and what we're left with downstairs is just 2. So the final answer is negative x squared over 2. Okay. So hopefully that was pretty painless. This is definitely a Math C problem. It happens to be a pretty easy Math C problem, but we would not have done a problem like this in Math 81 because it does require factoring. All right, so I'm going to take that x squared plus x. We can factor that. And again, everybody is a factoring expert at this point. That's just a GCF factoring. I'm going to pull out an x, which is going to leave me x plus 1. And we'll keep this 8 down here, and we'll keep the 16 and x plus 1. Okay, so now everything is factored. So I guess the first thing I can do is get rid of the x plus 1s. And then the other thing I can do is I have a common factor 8 between the 8 and the 16. 8 divided by 8 is 1. 16 divided by 8 is 2. So your final answer is going to be 2x over 1, which in simplest form would be written 2x. All right. When there's a 1 on the bottom, you do not have to write the 1, and I would encourage you not to write it in your final answer. Your online homework program, I honestly don't know if it would accept the answer 2x over 1 or if it would tell you it's not in simplest form. Try to get in the habit of not writing over 1 in your final answer. It's just not necessary. All right, and then finally we have this kind of scary looking thing. It's just factoring, and you're all factoring experts. All right, so the first thing I see is, you know what? At this point, you should pause the video and try to factor all these things, and then come back and compare notes. Okay, so go ahead and do that. And now I will assume that you have done that. Okay. First thing I see in the top left is a difference of 2 squares. That factors into x minus y, x plus y. In the bottom left corner, that looks like just a GCF. The GCF is 3x. Pull out 3x, you're left with x plus y. In the top right, that's another GCF. Pull out 3x, you're left with x plus 2. And now probably the hardest thing is this bottom right here. So that's that x squared, xy, y squared pattern that we talked about in chapter 6. I would use the trial and error method for this because there aren't really a whole lot of things that can possibly work. The only way to get 3x squared would be from 3x and x. The only way to get y squared would be from y and y. So now I just have to figure out how to put the signs. In order for that middle term to come out to be minus 2xy, I think you need the minus here and the plus here. Okay. Remember, you can always check that using FOIL. All right, and now my favorite part. We get to cross stuff out. So the first thing I'll cross out is x plus y. Next thing I'll cross out is 3x. You could cross out the 3's and then the x's. They are separate factors. But since I have both of them, I'll just go ahead and cross them both out. And then the other thing I see is x minus y. I have one here and one here. All right, so final answer, x plus 2 over 3x plus y. All right. So multiplying rational expressions really isn't too bad, okay? I guess the most time-consuming part of it is the factoring. So you can see why it's so important to be a factoring expert, right? Okay, that brings us to dividing rational expressions. Oh, I don't think I wrote this one down on my tablet. Let me go ahead and do that real quick. 2/5. I mean, again, I know you know how to do this, but I still think it's worth talking about. Okay. All right. I don't know. In my experience, people seem to remember this rule reasonably well. So the only extra step with dividing fractions is that you start off by changing it into a multiplication problem. We are going to multiply by the reciprocal, right? Okay, and now it's just a multiplication problem, and we've already talked about how to do those. So in this case, it's going to be 2 and 6. You can take out a factor 2. 5 and 35, you can take out a factor 7. And the answer is 7/3. And remember, we don't mind improper fractions as answers in algebra, unless maybe it's a word problem, and then I might write it as a mixed number or as a decimal. All right, so the rule is P over Q divided by R over S. You change it into a multiplication problem by flipping the second one. And then it's just a multiplication problem, exactly like what we were just talking about, right? Simplify as you go along, usually is the easiest thing. Remember, before you can simplify, you have to factor, okay? So I have two examples of dividing rational expressions, and now I have to get back to that page on the tablet. I had to skip to the end in order to sneak that other thing in there. Here we go. All right, 7a squared b over 3ab squared. We're dividing by 21a squared b squared over 14ab. So the first thing I'm going to do is write that as a multiplication problem times 14ab over 21a squared b squared. All right, and again, I would say this is probably a Math 81 multiplication problem. I don't remember if we did division problems in Math 81. It really doesn't. Okay, so what do we see in terms of common factors? Well, I see an a squared and an a squared. And by the way, there are a whole bunch of different ways you could do this. Let's see, the next thing I see is I see a 14 and a 21. Why don't we divide those both by 7 and we'll get a 2 and a 3. And then I can take this b and b squared. 2 minus 1 is 1. And because the bigger exponent is on the bottom, that leaves b to the first power on the bottom. And then the same thing over here. And I think that's about all we can do, right? Oh no, there's one more thing, but I've run out of colors. Let's see, gray. I don't think I've ever used this before. I have an A and an A. We can get rid of those. All right, lots of stuff. So that leaves us with 7 times 2 is 14. And then on the bottom, I have 3 times b times 3 times b, which I will write as 9b squared. Okay. All right, on to letter B. As usual, whenever you want to try one of these, I strongly encourage that. Try it, pause the video, try it, and then come back and compare notes. All right, so I'm going to assume that you've tried this. First thing we're going to do is write it as multiplication times x squared plus 2x minus 8 over x squared plus 3x minus 18. Now I have some stuff to factor, right? I have to factor those trinomials in the second expression. X minus 3 over 2 minus x. And then this is easy factoring over here, right? This is from section 6.2. So numbers that add up to 2 and multiply to negative 8 would be positive 4, negative 2. And then numbers that add up to 3 and multiply to negative 18 would be positive 6, negative 3. All right, so we can get rid of x minus 3. Now, do you remember the shortcut that we talked about in the last section? I'm looking at that x minus 2 and 2 minus x. Do you remember how I told you to deal with that? I have an x minus 2 on top. I have a 2 minus x on the bottom. I can cross those out as long as I promise to leave a negative 1. All right, so we have x plus 4 over x plus 6, and the whole thing is times negative 1, so why don't we write that answer as negative x plus 4 over x plus 6. Done. All right, and I think that's going to do it for multiplying and dividing rational expressions. All right, so now we get into unit conversions. All right, so I have a visual aid for this. I am a child of the 80s, and in the 80s, Rubik's Cubes were very popular. And I use this as a visual aid to help you kind of understand why this works the way it does. So imagine that one side of the Rubik's Cube is 1 yard, very, very large Rubik's Cube. That yard is divided into 3 feet. So each colored square is 1 foot on a side. So a square yard, as you probably know, is a unit of area. A square yard is a square that's 1 yard by 1 yard. So the whole side of the Rubik's Cube, we're saying, is 1 square yard. And hopefully you can understand why it's divided into 9 square feet. It's because you have 3 feet over here, 3 feet going along here. 3 times 3 is 9. And then a cubic yard is a measure of volume. So that would be the volume of the whole entire Rubik's Cube. And it is divided into 27 small cubes. All right, imagine there's one all the way in the center. I don't think there actually is, because when I was a kid, we used to take the Rubik's Cubes apart to cheat, and then put them back together and say, oh, look, I solved it. All right. So hopefully that visual aid helps you. I'm always hearing people say, Mitchell, how am I ever going to remember this? Not so much in an online class, because, I expect you to make a little cheat sheet. You can use all your notes if you want to, but when you're taking, a quiz and you only have 90 minutes, you spend a lot of time flipping through all your notes to find the things that you need, which is why I encourage you to, you know, write down the most important things on 1 or 2 sheets of paper, and then it's very easy to find, right? Okay. Then we have this, feet and inches. I'm not going to actually do this. If we were in a classroom together, I would probably take my marker and start chopping one of the little colored squares into a bunch of much smaller squares. I'm not going to try to do that on here. All right. But it's the same idea. There are 12 inches in a foot, which means if we talk about a square foot, which is again a unit of area, 12 times 12 is 144. So imagine that this one little yellow square is divided up into a bunch of much smaller squares. There would be 144 of them. I don't know how long it's been since you've looked at a multiplication table. A multiplication table is a good example of like a 12 by 12 grid, right? Where it has all the answers to your little multiplication problems on it. And there might be 144 of those things on there because it's 12 numbers going down this way and then 12 numbers going across this way. All right, and then a cubic foot, which would be one of these little cubes, divided into much, much smaller cubes. There would be 1,728 of them because that is 12 times 12 times 12, okay? So when you realize that this is just 3 squared, 3 cubed, and this is 12 squared, 12 cubed, it makes it easier to remember, okay? All right, so what I'm gonna show you now, and this is one of those things, I have a few things that are like this, things that I never learned in school, all right? But that I'm very happy I learned later. And one of them is this method for unit conversions, okay? It's a very nice systematic method, you know, not a lot of guesswork involved. Let me show you how it works. And again, hopefully you nursing majors especially will really appreciate this because in your work, you have to do a lot of unit conversions. Not so much with yards and feet and inches, but cubic centimeters, all right, and you know, stuff for measuring out medicine. All right, finishing up this video on another day. I had some major technical difficulties the other day. That's why you may notice I'm wearing a different shirt. All right, so we're talking about unit conversions. So let me show you the method that I was just telling you about. In this problem, we're converting 1,008 square inches to square feet. So what I'm going to do is I'm going to write down 1,008 square inches. And now remember, this is in the section on multiplying rational expressions. So the reason it's in that section is because I am going to multiply 1,008 square inches by a form of 1. In fact, let me do this. I'm just going to say times 1. You don't have to write that step when you do this yourself. Okay, I'm seeing a little bit of lag on here the way that I'm having to do this now. Could not get my tablet to come back up doing it the way that I've been doing it for a long time. Hopefully this will work. All right, so the form of 1 I'm going to use is going to do this. I'm going to put, first of all, I'm going to put a 1 underneath 1,008 square inches. And then I'm going to put square inches down here, and I'm going to put square feet up here. So remember, I need this expression right here to equal 1. All right, I'm going to take away that circle now. And the way that I'm going to do that is referring back to the last slide. Remember, we saw that there are 144 square inches in 1 square foot. So because those two measurements are equal, that makes that second rational expression equal 1. The square inches are going to cancel each other out, and that tells me that the number of square feet in 1008 square inches is 1008 divided by 144, which I believe comes out to 7. So there are 7 square feet in 1008 square inches. All right, next example. This one is going to take one extra step because, again, referring back to the last slide, I don't have anything that converts cubic yards directly into cubic inches. I can convert cubic yards to cubic feet, and then I can convert cubic feet to cubic inches. So that's what I'm going to do. So just like in the last example, I'm going to take my original measurement. And now, since I can't convert cubic yards directly to cubic inches, I'm going to start by converting it to cubic feet. Now remember, you need to place the units so that the units that you're trying to get rid of will cancel. So again, I'm going to put or in this case, I'm going to put cubic yards in the denominator, and upstairs I'm going to put cubic feet. And let's see, I believe there are 1,700, no, let's see. Oh, okay, so then, oh, I'm sorry, no, the number of cubic feet in 1 cubic yard is 27. Okay, so it's a good thing you don't have to memorize this, right? You can have this in your, or on your cheat sheet. All right, so that's going to get rid of this cubic yards and it's going to put it in cubic feet. But of course, I want it to be in cubic inches. So the way I'm going to get that done is I'm going to multiply by another form of 1. So this time I'm going to get rid of my cubic feet and change it to cubic inches. And the number of cubic inches in 1 cubic foot is 1,728. So now my cubic feet will cancel, and I see the only unit left is cubic inches. So now I fire up my calculator, which I probably should have had open before I started. 1,728 comes out to 93,312 cubic inches. All right, so hopefully this is starting to make sense. We have one more example. This is about as complicated as they'll ever get in here. And in this example, there we go. We're converting 930 miles per hour into feet per second. So some of these conversion factors are not on the last slide. All right, hopefully some of these you know. So the first thing I'm going to tell you is the word per, P-E-R, in math usually translates into divide. So if you have miles per hour or feet per second and you need to set that up as a rational expression, you can do it like this. 930 miles per hour, you write it as 930 miles divided by 1 hour, okay? So I need to get rid of miles and hours and replace them with feet and seconds. So I think I'll start by getting rid of hours. So this time the unit that I'm trying to get rid of is in the denominator. So to get rid of it, I'm going to put it in the numerator this time. And I think most people know off the top of their head how many minutes are in an hour. You may or may not know how many seconds are in an hour. But as long as you know that there are 60 minutes in 1 hour, that is good enough. And then we'll convert the minutes into seconds. Okay, notice the hours cancel, just like we know they need to. All right, now I'm going to convert my minutes into seconds. Again, we're trying to get rid of minutes, so I'm going to put the minutes unit in the top over here. And there are 60 seconds in 1 minute. Okay, so now the minutes are going to drop out. All right, so now the only other thing I need to do, I started with miles per hour and now I've got it in miles per second. All right, so we're most of the way there. Now we just have to convert those miles into feet. So do you know how many feet there are in a mile? I have to say most of the face-to-face classes that I talk to, most people don't seem to know that, and that's fine. Might be something to write down on the cheat sheet. Okay, so before we get into that, notice miles are on top in my original expression. So to get rid of them, I have to put them on the bottom. All right. So how many feet are in 1 mile? Well, there happen to be 5,280 for some reason. Okay. So now the miles are going to drop out. So let's look this over. On top, we have feet. On the bottom, we have seconds. So that should be what we need. So now what numbers do we have to crunch? We need to do 930 times 5280. And then we need to divide that by 60 times 60. All righty. So 90 divided by, or sorry, times 5280 equals, and then I will divide that by, let's see, why don't we do 60 squared? That's the easiest way. Did I do that right? That answer doesn't look familiar to me for some reason. I've done this problem probably 20, 25 times over the years. Divided by 60 squared. Okay, I'm glad I did that over. Okay, so that comes out to 1,364 feet per second. All right, and that's going to take care of section 7.2. So we'll see you next time.